Okay, so hi, we are Lucy, Thomas, and Selena from 9.1. Our project and fair is called the Saving Cream Experiment. You might ask why we choose this topic. So our purpose when conducting this experiment is to figure out the surface tension and the density properties of water in order to understand more about the precipitation process when clouds make raindrops from the sky. Here is how it goes.
First up, we will come to a project overview, which is the general look of the experiment. We have talked about purpose already, so the brief overview of this experiment is to do the experiment step by step. Next, record the data because we will do it twice, and finally give the conclusion. We asked about some questions. Students have submission related to this experiment. Our hypothesis is include our hypothesis for this is that the shaving cream will flow while the food coloring sink down for a while. Luckily, our conclusion and research summary are the same as the hypothesis. Here we will include some image of each experiment, but it will be shown more clearly afterward.
Next, we will talk about the purpose and research questions. Our purpose for doing this is to figure out the properties of water and how precipitation in a water cycle works. We will also compare the cold and normal water. Furthermore, we can comprehend water tension, which contains the cream, as well as how rain falls on the daily basis when clouds push water down the ground. While doing the experiments, we also ask ourselves questions like how will the food coloring move, drift, and dissolve in cold and plain water? How does surface tension relate to the shaving cream experiment? And is water density related to the shaving cream experiment?
Our hypothesis is that the shaving cream will float on top, and when the color drops down, the cup will somehow is the same with raindrop falling from the sky. We also predict that the ice glass will much slower and harder to dissolve, but just after seeing the result, there's still room for error in our prediction.
So to start the experiment, we will need two clear cups, one shaving cream bottle, about 3 to 4 different color of food coloring, normal water, and cold water.
In our experiment, we will make sure that we use the same amount of water and same amount of food coloring for each cup. Then we will wrap it on a shaving cream and wait for the same amount of time. In the video, the only thing that's different is the water. One class is cold water and one class is normal water. Any experiment needs step to do it, and the steps of our experiment are to fill 3/4 of our cups with water, shake the shaving cream, and label one cup cold water and another cup is normal water. Then spray a layer of shaving cream onto the top of water, and we must make sure to cover the surface of the water. Add the food coloring to the top of the shaving cream and finally sit back and watch as the food coloring works.
So that is all the first part of the project. Next is the conducting experiment part. This is our film video when we were doing the experiment, and I will explain it right now. So the first is to prepare the necessary materials. After having all of the experiment we need, uh, we will immediately start the process, the experiment. So this is when we pour the water into both cups, and one of the cups have ice in it. After that, put shaving cream on top of the cups And the last step is to put some drops of food coloring on the cream. Those are all the steps needed to finish this experiment, and the next thing is to wait. As soon as we put the food color on the foam, within 1 or 2 seconds it breaks the surface of the foam and dribbles into the water. After minutes of waiting, we can see that 2 cups have food coloring sinking down at the top and bottom of the cups. That also means the experiment was successful.
The phenomena after doing the experiment is the food coloring sinking down and a different color. It has a different color as speed. The reason why the liquid color pass through the foam is that the color is much denser than the foam. As a result, it breaks the surface of the foam and pass through it.
So here comes the slide with the result. So our collected data shows that it took about 10 minutes for food coloring to completely sink all the way down. We also see that an outline of factors such as too much shaving cream or a different amount of water can affect the result. We can see that the color in the cold water sinks faster and dissolves more effectively. The normal water class still sank, but it took more time and was not as effective as the cold one.
As I have mentioned, this is the comparison. The cold water makes the food coloring sink slower than the normal water, and also the colors kind of different.
So the result of this is that the cream sinks down and becomes saturated. And we also use red and blue, but we only recorded red, so it is fine when you see this is the picture of blue. So the red is created by the experiment.
These are the photos and diagram of our experiment. We have the material that we need to use for experiment. The process like pour the water in, shaking the shaving cream, putting the shaving cream on top of the water, and dropping a food coloring on top, and the result of the experiment.
So the final part is the conclusion. After doing this experiment, we can understand that ice water is denser than normal water, which causes the food coloring to sink faster. Substances dissolve at different temperature, and this experiment has also shown so. Our hypothesis is correct, but there is still a mistake in saying that cold water makes the food coloring to sink slower. We can see that the experiment has proven that there are substances that will dissolve very slowly at low temperatures and those that will quickly dissolve at high temperature. The watercolor has dropped down into the shaving cream, and in the cold water it vanished, and in normal water it does not melt and dissolve faster. In dyes, they will dissolve at high temperatures than at lower temperature. When you add cream to the water, the surface tension is weakened, and this elastic membrane breaks apart, which causes food coloring to move out into areas of low surface tension. The proof of surface tension is that food coloring moves into areas of low surface tension. And the proof of the density of water is that food coloring has a slightly higher specific gravity of relative density than water. Before the diffusion, it tends to sink in the water, and at higher temperatures, particles move faster. This faster movement allows diffusion to occur more quickly.
That's about the end of the presentation. There are citations and thank you for listening.